Hi everybody! So in today's video we're going to continue talking about graphical limits, but what we're going to do is look at making our own graphs so that we can then evaluate the limits using those graphs. So the first thing I'd like to do is review how we can graph a piecewise function, and then what we'll do is use this graph that we create to evaluate the limits that are listed below. So one of the things we talked about over the summer in the summer videos is that we could actually graph this function in two different ways. We could do it by making tables, or we could do it by knowing what the shapes of these graphs would be. So if we were to make a table, the first table I would have x and f of x. And I would start with 0, even though it says x is less than 0, and I would just make a note here that that's going to be an open circle on my graph. Now, other numbers that are less than 0 would be -1, -2, and -3. If I take those numbers and substitute them into this function, I'm going to have 4, I'm going to have 5, I'm going to have 8, and I'm going to have 13. The next section of this graph would be the middle section. Now, this says that the only value of x that we're going to use here is x equals 0. So the only value that I would list in my table would be 0, and I would make that a closed circle because x is actually going to be equal to 0. Now, if I substitute that in, I get that the y value would be 0 for that part of the graph. The last table that I would create would be x and f of x. It says x has to be greater than 0 for that part of the graph. So I would start with 0, then 1, 2, and 3. And I know that this 0 is going to have an open circle because it's not equal to 0 for that part of the graph, for that domain. If I substitute these numbers into that function, I get 4, 7, 10, and 13. Now what I'm going to do is actually make my graph. Now based on the shapes of these graphs, I know that the first shape should be a parabola. The middle one should just be a singular point because it's only going to have one x value, and the last part should be a line. So when I'm graphing these points, if that doesn't correspond to how I expected them to look, that's going to kind of give me a heads up that something probably went wrong. So now I'm going to start by graphing the point 0, 4, and I'm going to make that an open circle. -1, 5, -2, 8, -3, 13 would be off this graph. Because I know that this should be a parabola, I'm going to know to make this curve and draw an arrow there. Next, I'm going to graph the point 0, 0. And finally, I'm going to graph 0, 4 is already there, it's open. 1, 7, 2, 10. And again, I know that this should be a line, and 3, 13 would be off the graph a little bit, so it's going to look like this. So that's the function I'm going to examine to answer these limits questions. Now the first question is, what is the limit as x approaches 0 from the left? So I'm going to approach 0 from the left, and when I get close to that 0, I'm approaching this open circle. So the answer would be 4. When I approach 0 from the right, I'm getting close to this open circle, so the answer there would also be 4. F of 0 means what is the actual function value at 0? Where is the closed circle? In this case, that would be at 0. The limit as x approaches infinity. In other words, follow the graph as x gets bigger and bigger and bigger. What's happening to the y values? Well, as I continue to go to the right, the y values are getting bigger and bigger and bigger, so the answer would be infinity. And as I follow the graph to -infinity, so I'm following to these really, really far left x values, the graph is going to get taller and taller and taller, so it's approaching positive infinity also. Now that's what we do if we don't have a graph and we are going to make our own. But one of the other things that we need to know how to do is how to graph functions on our calculator and then use that graph to evaluate the limits. So as we're doing this, I would like for you guys to write down important buttons that you think you need to know where they are, just so that you're aware. So the first thing is, if we want to know the limit as x approaches 0 for sine of x over x, what we're going to want to do is graph that function on our calculator. Now in order to make the graph, the first button you're going to need to push is the y equals button. Now that's going to be in the upper left corner of the calculator. Once we get in there, we're going to type in sine, and then the x button is right here above where it says apps. I'm going to finish the parentheses for sine, and I'm going to put divided by x. Now it's really important to note that in calculus, you need to always be in radians mode. So to check to see if that's true, you would hit mode, and then make sure that radian is dark, which means you float over it and just hit enter to turn that on. Then I would hit, for number 2, zoom 6. Think about zoom 6 as being standard zoom. It's kind of home base. You start there, and if you need to zoom out or zoom in or change the window, you would do it after you have a look at what you get from zoom 6. Now I want to know what happens as x approaches 0. So I'm going to hit trace. And then I'm going to type in the x value that I'm trying to evaluate. So I'm going to hit trace. I'm going to hit 0. And you'll notice it says x equals 0 on the screen. And then I'm going to hit enter. Now you'll notice that on the screen we can see that x is 0 and y does not have a value. The reason that y does not have a value here is because when you actually take 0 and plug it into this function, you get an undefined value because there's an x in the denominator. So what we're going to do now is just push the right button. So kind of think about that as slide to the right. I can see that the y value close to there is 0.99, which is like 1. Slide to the left. I can see that the y value close on the left is also 0.99, which is close to 1. So what I'm going to say here is that my limit is approaching 1 because I checked both sides by sliding to the right and sliding to the left. To check both sides. And that's what allowed me to check to see if they were the same, which they were, and they're both close to 1. So now we're going to go ahead and repeat that process for number 2. So I'm going to go to y equals, clear what's there, parentheses x squared minus 1, divided by parentheses x minus 1. I'm going to do zoom 6 to get my standard zoom. You'll notice it looks a lot like a line. Now I'm going to hit trace, and I'm going to type in the x value that I want to approach, which is 1, and I'm going to hit enter. You'll notice again it's undefined. The reason is because if you take the number 1 and you plug it in here, you get a 0 in the denominator, which obviously is an undefined value. So now I'm going to slide to the right. I get 2.276. I'm going to slide to the left. I get 2.06. So it looks like I'm pretty close to the number 2. So when I'm pretty close to the number 1, I'm pretty close to the number 2. So it seems like my y value here is approaching the number 2. Next, we're going to try the limit as x approaches infinity. So we're going to go to y equals and type in this function, square root of 9x to the 4th minus 2x divided by parentheses 6x squared. I'm going to go to zoom 6. Now here's the thing about having x approach infinity. That means we want very, very, very large x values. And right now my x values only go up to 10. So what I'm going to do next is I'm going to go to Window, and I need to increase the size of the x values that I can see. So x min stands for the smallest x value that I can see. Well, if I want x to be super huge, then I'm going to make my smallest x value like 1,000. X max stands for the largest x value that I'd like to see. Now I want my x's to be really big, so I'm going to make that like 5,000. I'm actually going to make this like 4,000 and this 5,000. Now I'm going to click graph to see that graph again. Now what I'm looking at here is the part of the graph that starts at 4,000 on this side and ends at 5,000 on this side. I'm going to click trace and I'm going to start sliding over. It looks like no matter what x value for these really big numbers that I'm picking, the y value is 0.5. So my guess would be that my answer here would be 1/2 or 0.5. Now, if we wanted to look at x approaching negative infinity, let's see how that would work. So I'm going to go back to my y equals. I'm going to type in 3x to the 4th minus 5x squared, parentheses, divided by, parentheses, 6x squared. The parentheses are really important because it tells your calculator what belongs in the numerator and what belongs in the denominator, so make sure you're typing those in. I'm going to go back to my window. Or actually, I'm going to zoom 6. I hit the wrong button. Sorry. This will take a minute. I'm actually going to zoom 6 to just get my standard zoom, and then I'm going to reset my window to make sure I'm looking as x approaches negative infinity. So you'll notice that this graph looks a lot like a parabola. I'm going to go to my window, and now I want very, very, very large negative x values. So I'm going to have negative 5,000 and negative 4,000 as my bounds there. I'm going to go to my graph. I'm going to take a look at what's happening here. Now if I hit trace and I start sliding more negative, so I'm hitting the left arrow, it looks like my values for my y values just keep getting bigger and bigger and bigger. It's not the same number every time like it was when we did the previous problem. It's like getting bigger and bigger. So that tells me that this answer would be infinity, because it's very, very big, positive numbers. Now, one last thing. Sometimes you're going to be given a table of data, and when you have this table of data, you're going to be asked to evaluate some limits. Based on this table of data, because these x values are 0.99, 0.999, 0.99999, 0.99999, and then this is 1.00001, it looks like these are numbers that are a little bit smaller than 1, and these are numbers that are a little bit bigger. So it seems based on this table that the missing number in the middle would be 1. It also seems based on this table that these numbers are getting progressively closer to 2 on both sides. Now, given that information, based on our numerical values, we would say that the limit as x approaches 1 would be 2. Now, if I wanted to sketch a possible graph of what's happening close to that x equals 1 value, I'm going to start by just drawing a blank set of axes here. So I care about, based on this table, what's happening when x is close to 1. It looks like the y values are approaching the number 2. So, because there's no value filled in here, I can't promise that it actually touches the number 2. So I'm going to put an open circle there. And then I'm noticing that when I'm bigger than the number 1, my numbers are bigger than 2. So from here, I'm going to make my numbers go up, my graph go up. And when I'm less than the number 1, I'm less than the number 2. So from here, I'm going to make my numbers decrease. If we try this again, if we look at this table, we've got negative 0.01, negative 0.001, negative 0.0001. It looks like these numbers are pretty close to 0. These are some very small numbers. And on this side, again, very small numbers close to 0. So I would make this a 0. And then 0.996, 0.9997, 0.9998, 0.9999, it seems like these numbers are approaching the number 1. So based on our numerical values, we would say that when x approaches 0, my y value approaches the number 1. Now, if we wanted to sketch a graph, a possible graph, because we're not making any promises, but this is just our best guess of what's happening close to 0. I'm just going to draw some blank axes. I know that when x is close to 0, it seems like y is close to the number 1. So I'm going to go ahead and put an open circle there. And then it seems like when I'm bigger than 0, positive numbers, These numbers are smaller than 1. So I'm going to make this side of the graph go down. And again, it seems like when I'm less than 0, these numbers are also smaller than 1. So I'm going to make this side of the graph also decrease. And that's it. Thank you guys so much for watching. Have a wonderful afternoon, and I will see you soon.